Hello there everyone, my name is Crazy Caleb, and today we're going to be taking a look at another not modded module tutorial. And today we're actually going to be covering the last of the easy modules that are considered in the not modded modules made by Speaking Evil specifically. So this is pretty much going to be the last module that we go into, before we get into some of the more trickier ones such as not the bulb, not EXO1, not coordinates, and even not murder. I am going to let you know that I'm going to save the color flashes for another time. Those will be together more, so you'll see not color flash with that group there. But let's get into not connection check. So the biggest difference is between not connection check is actually the way that the highlight is present on the module. They're a bit more out there, I'd say. That would be the best way to describe this. The actual LEDs look a little bit different because when you hold it down, you're actually going to receive a message in Morse code. So that's going to be the biggest difference of how you're going to be able to tell this module apart. Normally, with a connection check in this case, you'll be able to interact with these buttons freely as you want to, changing them between red and green. But holding it not connection check in this case, for each LED it transmits a Morse code character. And so what we must do is we're going to get these Morse codes for each 4 characters, and we're going to submit them in a specific way based off of the last digit of the serial number. So let's get into this. So how exactly do we read these Morse code characters? So we're going to hold it down, and we're going to simply read off the Morse code. And the way that we read what we're going to be reading for Morse code is the color that is opposite the one that is before holding it. So in this case, the color that is opposite is red for this top left one right here. That is what's going to be transmitting the Morse. The green will simply be the breaks in between, and as it mentions here, the gaps in the transmission are the same color as the LED when not selected. So that's what we're going to be looking for here. So let's take a look and see what Morse code characters we get. So in this case, the first one is waiting for the reset. So dot dash, dot dash, dot dash. And that's our first character. So dot dash, dot dash, dot dash. Which in this case, let's take a look at the Morse code for down here. In this case, that corresponds to a period or full stop. So let's actually just note that down. And that's what we're going to note down for that character. Let's do the same for the other 3. So in this case, we have waiting for the break, because it sometimes can start at a bit of a weird spot. So it's important that we make sure that we make sure we're starting from the beginning. So dash dash dot dash dot dot dash. Okay, hold on. Dash dash dot dash 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 dot dot dash dash. So dash dash dot dot dash dash. In this case, corresponds to comma. Alright, that's our second character. So next up, this one is now going to be transmitting in the color of green. So that would be the way that we're looking at this Morse code message. Dash dot dot dash. Or it's dash 1 2 3 4 dash. So dash 4 dots and 1 dash at the end. So in this case, that bottom left is a minus symbol in this case. For our last symbol, dash, wait till it resets, dash dot 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 dash, dash dot 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 dash, dash dot 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 dash. Sorry, I'm reading this all wrong. Hold on. So let's hold it again. Dash dot 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 dash. Yeah, dash dot 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 dash. In this case, corresponds to equals. So now what we're going to do is with each of these 4 characters that we're given, we're going to use the 2 numbers that correlate with that specific symbol, and we're going to do a specific operation based off of the character that we got. So in this case, our first character was the period, or the full stop, and what this operation wants us to do is the additive digital root of the product. So what exactly does this mean? So we're going to do the product of 2 and 6, so in this case, 2 times this by 6, in this case is going to be 12, and we're going to do the additive digital root of that product. So the additive digital root, for those of you who don't know, digital root is basically you add all of the numbers up together to get one single digit remaining. So in this case, we're going to simply add 1 plus 2 to give us 3. And we're going to replace that character 3. We're going to replace that character with that 3. And that will be our answer for that specific coordinate, position on the module. Next up, we got the comma. Now, this is the one where we are going to actually take a look at this table here. And this is the only one that we're actually going to look at the table for, so it's important that you understand this rule. So we're going to index into the table on the right, as I said, and the first digit is the row from bottom to top, and the second digit is the column from left to right. So in this case, it is an 8x8 column, and this is actually the maximum character that you can get. So in this case, this bottom left corresponds to 1, 1 in this case, because we cannot actually get a 9 on this display. So using the numbers actually won't help you here to differentiate the modules from connection check and not connection check. There will always be numbers between 1 from 8 in both modules. So the first digit on the left, in this case, is going to correspond to the row from bottom to top. So we're going to be looking at the first row. And the second digit is the column from left to right. So 1, 2. And in this case, we get the number 4. And that will be our answer for, excuse me, I did actually the wrong one. In this case, we're looking at 7. So 7 from the top to the bottom, in this case, is 7 right there. And then 1, 2, 3 is also 3 in this case. My apologies. I was looking at the bottom right in this case. So we also get 3 for this answer. So next up is a minus. So next up for this bottom left character using 4 and 5, we're going to use the absolute difference of this operation. So in this case, 4 minus 5 in this case gives us -1, which equals 1, because we're going to do the absolute value of that, which means we get rid of the negatives. Or we can simply just do 5 minus 4, in this case giving us 1, same result. So that is going to equal 1 for that bottom left part. And our last character is equals. So now this is where things get a little bit weird. So we're actually going to be using logic in this case for 2 of these rules, XOR and XNOR. So we're going to bitwise XNOR on the last 3 bits. So for each bit, for each number in 1 and 2, we're going to break these guys up into binary. So in this case, 1 in binary is 0, 0, 1, because it's simply just adding 1 at the beginning right there. And for 2, it's going to be 0, 1, 0. So that's how this looks like. So for those of you who aren't familiar with the logic gate of XNOR, XNOR in this case is simply doing XOR, but not that. So, and the way that XOR works is that XOR is either it's going to be 1 is exactly true, but not both or neither. So it can be either 1, 0 or 0, 1. What XNOR does is it simply does the opposite of that. In this case, if both are exactly the same, that is true. And in this case, the only time where that applies is this first bit, in this case right here, is 0, 0. So that will be a 1, and these other characters will be 0, 0. So now we're going to convert this back into base 10 numeral form. So in this case, this answer will be 4, because 2 to the power of 0 is 1, 2 to the power of 1 is 2, and 2 to the power of 2 is 4. And these will be our 4 numbers that we're going to use right here. So now, what we're going to do is, once we have our answers, we're going to hit check. All of the modules will currently be displayed as red now, and we must press these buttons in a certain order based off of the last digit of the serial number. In this case, our last digit is a 6, so we're going to press them in even ascending, then odd ascending. So we're going to do even ascending. In this case, there's only 1 even, so that's 4. And then we're going to do odd ascending. And in this case, we have 2 3s, so actually the order does not matter as long as you hit this 1 first, because that comes first before 3. And just like that is a solved module. Let's take a look at another example here. So this module actually does require you knowing a little bit of logic, binary, a bit before this stuff, before actually learning this module. So it's important that you know that. So yeah, let's take a look at this next example. So dash, dash, dot, hash, dash. So we're getting the comma again for this stage. So now for this character, let's wait for the reset. So dash, I missed that. Hold on. dot dash dot dash dot. In this case, we're looking at dot dash dot dash dot, which is a plus. Dash, okay, let's take a look. Dash 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 dot dot dot. Dash 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 dot 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 corresponds to colon in this case. And lastly, for bottom right, dot dash dot dash dot dot. So dot dash dot dash dot dash, and that's it. So dot dash dot dash dot dash. In this case, corresponds to period. Now let's use comma for our first number. So indexing from the table again, the first digit is the row from bottom to top. In this case, that first digit is a 3, so 1, 2, 3. And then the second digit, in this case being 4, is the column from left to right. So 1, 2, 3, and 4. And that number gives us, and that will give us a 5 as our result. Next up, we're going to take a look at plus. And in this case, our operation is the last digit of the sum. So 5 plus 7 in this case will give us 12. And since we're looking at the last digit of the sum, we're simply going to get 2 as our result. So in this case, it's just the sum, and then we're going to simply mod 10. The next up is the semicolon. So it's the integer part of the larger digit divided by the smaller. And in this case, we also take a look at the slash character. It's quite the opposite of that. Instead of it being the integer part, it's the remainder of the larger divided by the smaller. To make sure we're able to differentiate between these two guys. So in this case, let's pull out our handy dandy calculator. So in this case, actually 3 divided by 3 is 1. And if we happen to get slash in this case, that remainder would be 0. Or simply what you can do for this guy is take the larger number and modulo the smaller number. That's the way that can work. But in this case, it's the integer part of the larger divided by the smaller. So in this case, we get 1. And for our last character, we have period. Period is the additive digital root of the product. So 5 times 2, in this case, gives us 10. And then 1 plus 0 gives us 1. And that will be our number corresponding to bottom right. So let's take a look at the last digit of the serial number in this case. That corresponds to 2. Let's hit check. And what we're going to do is we're going to hit even ascending, then odd descending. So even ascending, in this case we only have 1 even, and then odd descending. So in this case we're going to get 2 to take care of all of our evens, and then we're going to hit odd descending, in this case being 5, and then 1, 1. And just like that is a solved module. Let's take a look at one final example and see if we can get anything different. Okay. So honestly, the hardest bit about this module is actually not the work, it's actually getting the read for the Morse characters. It can take a little bit of work to get used to reading the colors in the opposite colors, because of the fact that each time it can be a different color that you're reading. So for example, going from reading red on this top left one and reading green on the top right one can be a bit tricky to maneuver, but with practice it will be much easier. So let's take a look at this final example. So dot dot dash dash dot. So it's dot dot dash dash dot, maybe? Let's wait for the reset. Dot dot dash, hold on. Dot dot dash dash dot dot. So dot dot dash dash dot dash, perhaps. Good. Dot dot dash dash dot dash, yeah. So that will be the underscore in this case. Then next up we have, waiting for the reset, dash dot 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 dash. That's 4 dots, so in this case that's going to be our minus. So, and then lastly, dash dash dot dot dash 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 dot dot dash dash, that's comma. And then lastly for our bottom right, wait, dot dash dot dash dot dash, or dot dash dot dash dot. In this case that corresponds to a plus. Another simple case, and let's take a look here. So in this case we have our underscore. we're going to bitwise XOR on the last 3 digits, the last 3 bits in this case. Let's convert 3 and 8 to binary, so that's going to be 0, 1, 1. And notice that we have 8 here, so for those of you who are familiar with binary, 8 is going to be 1, 0, 0, 0. And why that is in this case is because of the fact that 2 to the power of 0 is 1, then 2 to the power of 1 is 2 for the second bit, then 2 to the power of 2 is 4, and 2 to the power of 3 is 8. But in this case, we're actually going to be using the last 3 bits. So in this case, we're actually not even going to see that 1 that corresponds to the 8. So in this case, it's going to be 0, 0, 0. Now we bitwise XNOR the last time, but in this case, we're going to be bitwising XOR. So for XOR, we have to have exactly one of the 2 bits be 1 in this case. And in this case, that does not correspond to the first bit, but it does correspond to the second 2. And then we're going to convert this guy back into binary, back from binary into base 10, which in this case is 3. Because 2 to the power of 0 is 1, and then 2 to the power of 1 is 2. 2 plus 1 is 3. Next up, we have the minus, is going to be the absolute difference. The absolute difference of 6 and 4 is going to be 6 minus 4 is 2. So 2 will correspond to the top right. Then next up, we have the comma in this case, doing what we did before, 2 and 2. So 2 for our row, and then 2 for our column, which corresponds to 3. And then lastly, our plus is the last digit of the sum. 1 plus 2 is 3, which is pretty nice, actually. So in this case, let's say check, and our last digit is 0. And simply 0 is going to be ascending. So we're going to hit all of these guys in ascending order. So 2, 3, 3, 3. And just like that is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.